Hello everyone and welcome to class. In this cybersecurity analyst certificate course, we'll be learning about the O.S.I model and how important it is for network communication. Previously, we've learned about the TCP/IP model and looking at how it helps in network communication. In today's O.S.I model course, we're going to learn deeply how the O.S.I model really works, and O.S.I model is an expansion of the concept of the TCP/IP model. So the TCP/IP model is able to explain how communication works in the network from the application phase and also to the transport phase, to the internet phase, to the network access phase. But in the O.S.I model, we're able to understand basically a deeper aspect. For example, in the TCP/IP model, the application phase there in O.S.I model is presented or represented by application, presentation, and session. So application, presentation, and session is what represents the application in the O.S.I model, in the TCP/IP model. So in O.S.I model, we have theory to represent application in the TCP/IP model. So transport in O.S.I model is the same as transport in the TCP/IP model. Then we have network. Network in O.S.I model is the same as internet layer in the TCP/IP model. Where we have the data link and physical in the O.S.I model is now what we have the network access in the TCP/IP model. So basically, you're going to understand it. Just take your breath and let's begin. So the O.S.I model is not difficult. It's the open system interconnected model of which was created by ISO in 1984. So it's a standard model to understand how connection works or network communication actually works. It all begins with the application layer. So we have 7 layers compared to TCP/IP where we have 4 layers. So there's a shortcut that we use to represent it. We start from the bottom to the top. So we call it, please do not throw sausage pizza away. Please do not throw sausage pizza away. For the last time, please do not throw sausage pizza away. Please represent the physical. Do represents data link. Not represent network. T represent transport. Do not throw. Throw represent transport. Sausage represent session. Pizza represent presentation, and application, for application, that's away, represent application. So that is how the 7 layers of the O.S.I model is. Remember, it works from bottom to top and top to bottom. It just goes in that same order, from the top to the bottom, from the bottom to top. It just keeps moving like that for network to really work. So communication happens from application to physical, from physical back to application, and it keeps going that way. So application layer, let's start with the application layer really. So application layer is talks about the network applications that makes that means computer applications that use internet. So when we talk about application layer, we are basically looking at the network applications that use the internet. So example is Google Chrome, Firefox, even for Gmail, that's an email, Gmail, Outlook, and others. So before we can understand the application layer, we need to understand what the web browser is in the first place. The web browser is a network application that runs in your own laptop or your PC or whatever it is, and your web browser is one that helps you to connect to the internet. The web browser helps you to connect to the server or to the internet. So for the connection to be made possible, it has to use protocols. And protocols is more like set of agreed rules on how connection will be done, the direction of connection, and basically, the way connection will go. That is how a protocol works. So without protocols, there is no. Imagine that we have two networks that want to communicate with each other. We have maybe a laptop and maybe a palm top, a laptop, and a mobile phone. Now they may not have the same operating system. So how will they connect? So there needs to be a set of agreed rules on which connection can be done, because sometimes some of them don't have the same OS. Some of them, a smartwatch and a laptop can connect, but there has to be a set of agreed rules. That is what we call the protocol. So protocol is really set of agreed rules on which network communication can occur, an agreed rule of which files can be shared, of which internet connectivity can go. So these agreed rules is what we refer to as protocol. So for communication to happen, these layers must produce specific protocols to enable communication to go on. Now for the application layer, there are some specific protocols that happens, like the HTTP, hypertext transfer protocol. So, or HTTPS, that's for the secured part, is for allowing you to communicate or request information directly from the internet. So that is what the HTTP helps you to do. And the web browser are dependent on the application layer and application layer protocols to function. For example, we have the file transfer protocol is able to transfer files from your laptop down into the server. We have the HTTP or HTTPS is able to help you to surf the internet, to browse the website, and to surf the web and all of that. Email is simple mail transfer protocol that helps you to be able to send an email to someone, to another person. So for emails to move, and they have to be a protocol called the SMTP, simple mail transfer protocol. Then we have telnet for virtual terminals. So basically, the application layer is the one that is close to the end user. You and I interact first with the application layer. So that is how we are able to connect to the internet. That is how we are able to browse on the website. That is how we are able to even use emails and be able to use web browsers, applications, and all of that. It is because this application layer is able to supply protocols that aid communication through that network. So after the application layer, the data is passed down to the next line, which is called the presentation layer. So there's a passing of data directly from the application layer down to the presentation layer. So the presentation layer will receive the data from the application layer. Now, it will receive it in form of character and numbers, because when you're writing, where can I find pizza to buy in Nigeria, in Lagos, in Abuja, in where can I learn software development, where can I learn cybersecurity, how can I be a cybersecurity analyst? You present this in as text. But now, what the presentation layer will do is to present this information down the line, not as text, because it wants to present it to the to be in machine language basically. So instead of it to be in form of character and numbers, it's going to convert the character and numbers into machine understandable binary format. So this binary format of one and zeros. This binary format is easy for it to be assembled or be understood by the machine. So that is where we talk about the translation, right? So it translates the message from basic character that you wrote as text and translates it to binary form, so that it's easy for it to be transmitted down. Now, in this translation, there has to be a compression too sometimes of the bits to lower, so that it can be able to move down smoothly. And that's part of what happens in the presentation layer, and it's very, very useful, especially when we are doing streaming of videos and audios. And it's very useful because once it is converted and translated, then also compressed into lower bits, it's easy for you to video and audios to move and be streamed very easily. So another thing that the presentation layer does is encryption. It encrypts, it uses the SSL protocol. Remember, in the TCP/IP model, we just have the application, but here in the O.S.I model, you are able to have both the first layer, application, presentation, and session. This theory is what represents application in the TCP/IP model. So in the O.S.I model, we are able to see what really goes on rather, what really goes on. So after the you have interacted with the application layer, it is transported down and moved down rather to the presentation layer, where the presentation layer is able to present it down the line in machine understandable language and able to encrypt the data also. So and also able to compress the data. In encryption now, it wants to encrypt the data from the sender. So imagine that I'm communicating with you via the internet now. I'm sending information to you, right? Data to you. And that data I'm sending to you now, what it wants to do is to make sure that it encrypts it from my end, translate it down the line, and encrypt it at the end when you are sending it back to me. So there's an encryption to encryption. So that is what the SSL secure socket layer is doing. So it encrypts. That's where we have the HTTPS secured. So it does that with an SSL certificate. So when you actually browse to the internet, you are looking for a website, you are trying to access a web page or whatever it is. Maybe you are trying to check for djtconcept.ng. So you go with https dot slash djtconcept.ng. Now, the browser will first look, especially if it's an updated browser like Chrome or Mozilla, it will search for your SSL certificate. That you really have an encrypted certificate to ensure that the message that you are sending to the internet is encrypted, or the message you are requesting is encrypted and is there is no middleman that can be able to go in between to check eavesdrop or even be a man in the middle to exchange the data that is going on. So what it does is it encrypts the data, and through the encryption, the protocol that is used is the SSL protocol, and that happens in the presentation layer for encryption of data, and when it comes back for decryption of data. So it does two things: it encrypts it when it's going, and when it gets to the end, when it's coming back to it also, because when it gets to the end, it gets to the physical layer. As it gets to the physical layer, it's going to come up back from physical, is going to come up back to data link, to network, to transport, to session. When it gets back to the presentation, it will decrypt it again and send it back to the application layer, where you and I can be able to visibly see what's going on. So it helps to maintain integrity of data before transmission, and data is encrypted. So at the sender side, data is encrypted. At the receiver side, data is encrypted. So presentation layer does a whole lot of job. Now, the three core functions of presentation layer now is transmission of data. It also does the translation of it, then compression of data. It also does encryption of data. So don't forget those three things: transmission, compression, and encryption at the presentation layer. It presents the data that you send into machine understandable language, translates it, encrypts it, and compresses it as it moves down the line. Now we can move to the session layer. So session layer is if you have a bit of knowledge about web development, or you have worked with backend, you will be able to understand what session is. And if you don't even have that knowledge, as long as you have encountered, you've logged into a website, even to the DJT website, you have experienced session. So session occurs when there's a complete successful connection between the user and the database. So now if I'm trying to access my account, I put in my username and password. If I'm able to get the two correctly, I'm connected successfully. So that successful connection is called a session. So with a session, I'm able to access basic things that are needed for me to do my work. So in doing that, if depends on how the security of the company or the security of the website or the application is, there could be a session out. So it depends on, it might be after some time of inactivity, I can be logged out, session out. So that session is ended. So a new session has to start again. So that's how it is. So session helps in setting up and enabling connection. It helps to set up and enable connection. It helps to help in sending and receiving of data. So during the session, data is being sent and received. So if I'm logging in, I can be able to send data, I can be able to receive data, I can be able to send data and be able to receive data when there's a successful connection. So that session helps in setting up the a connection to enable and receive data. And it does this through many means, right? So in the session, we could find things like APIs, we could find and different things opening up in the session, because session allows computer to talk to each other, even humans to be able to connect with computer and your dashboard, whatever it is. So don't get it confused. Just see a session as a successful connection. So in the session, something is very important, and that is where we talked about. Remember in domain 5, we talk about IAM, identity and access management. So under IAM, identity and access management, we're able to talk about authentication and authorization. So we talk about authentication, that's verifying your identity, and also when your identity is being verified, you can now move on by getting access depending on need to know, least privilege or whatever it is. So if you remember that, you can continue. So in this part, session part, we are able to have authentication and authorization. It tries to authenticate the user. Who is this person that is trying to come into this network? Do you really have the authority to come in? So it tries to check and sees if you have the required authority to come in or the right access to come in. So it checks through by authenticating you, maybe through a username and password. Then once you're authenticated, it now gives you the level of access that you deserve for your duty. So authorization talks about the level of access authorization that you have. So if you are maybe a cybersecurity analyst, your level of access will be different from someone that is a manager or whatever it is. Then if you don't have access to a particular file, it will just write it there that you are not permitted to access this file or whatever information it writes there, because from the session layer it has discovered that you don't have the right access. All right, so session layer helps to keep track of files too that are being downloaded. In session layer, you can also be able to keep track of what files is being sent, and text files or image files or whatever it is. And what it does is, the session layer is able to connect to the database very easily. So it tries to store different things in different places. Text is stored in text. Images are stored in the image part of the database. So it helps to know what is being sent, keeps a track of what is being sent from text to text, from image to image, and thereabout. So session layer helps in three major things. It helps in session management, to manage session, session in, session out. It also helps in authentication. It helps in authorization. So session is very, very important. So basically, our web browser helps in these three main things: in application, presentation, and session. And in TCP/IP model, that is exactly what your application is. The application layer in the TCP/IP model is application, presentation, and session in the O.S.I model. So I believe that is a little bit clear. We can now move into the transport. In transport, just like in the O.S.I model, in the TCP/IP model, is basically for ensuring that your communication is moved reliably. Transport is what ensures that it actually gets to the right destination. The data flows to the right destination. So in the transport, it controls reliability of communication, and it does this through three main channels: segmentation, flow control, and error control. So in segmentation now, the data that is received from the session layer, remember, is going from the application layer down to the layer, and presentation layer is going down also to the session layer. So from session layer now, it receives the data, and data that is received from there is divided into what they call segments. That's why we talk about segmentation. And in those segments, in a segment you could have the port number, and the port number, which consists of the source and destination, and also the sequence number. So we could have the port number here that carries, your packet will carry the header and the payload. So basically it carries basic information of the source and destination. So through the port number, it's able to go to the required application. Whatever the port number helps to direct each segment to the application, while sequence helps to reassemble the segments in the correct order. to form correct message after at the receiver. The sequence number helps to reassemble segments in the correct order so that it can form correct message to the receiver. So the transport is very important. It ensures reliability of information. And there are two main protocols used here, the TCP and the UDP. The TCP talks about the transmission control protocol, and UDP talks about the user datagram protocol. In both of them, one is faster, but one is more reliable. Just like we said in the TCP/IP model, the TCP is more reliable, while the UDP is faster. UDP ensures speed, but TCP ensures the fact that the information gets to the required destination. So UDP is faster, is used for things like video games and thereabout, and for music and video streaming. That does not require the fact that it must report that it has gotten to the end. So TCP always provides feedback, but UDP doesn't provide feedback. You just, soldier go straight away, obey the last command, go. That is UDP. So we talk about flow control too. Yeah, under TCP, under the transport layer, it also does flow control. That means it controls the amount of data that is being transmitted. And error control, like I said, TCP always does what they call a feedback. So if data is sent and does not arrive at its destination, the transport uses what they call the automatic repeat request. It will automatically repeat the request again. If it discovers that, imagine that you send information to a particular person, if it doesn't go there, then it will receive a signal that this thing has not gotten to where it's going to. It will now do an automatic repeat request, and it keep repeating and keep repeating that way. So TCP is to ensure reliability of communication. The transport layer passes data segments to the network layer. The data unit in the network is called the packet. We've talked about that before. So let's now talk about the network layer or the internet layer in the TCP/IP model. In the network layer now, we have three main parts functions here. We have, we talk about the IP addressing too, or what we call logical reasoning. We talk about path determination, the path of which it will be routed, it will flow, and we talk about routing. Three things: logical reasoning, addressing, path determination, and routing. So IP addressing, or what we call logical addressing, it helps to assign an IP address to each segment to form an IP packet. So the network layer assigns the sender and receiver IP address. Remember, we talked about the fact that in the internet layer, it assigns an IP to a particular device, because every device has an IP. So there's what they call the static IP and the dynamic IP, depends. So some devices have static IP, but for a device to connect, it must have an IP. Now, the reason I'm able to connect with you is because my device that I'm using to connect has an IP. Your device has an IP. So I'm sending to YouTube. YouTube is able to transmit what I'm saying to you because it's able to locate your IP address. So internet layer will attach an address to the device so that it is able to locate it. So there is what they call IP address. That's the internet protocol address, the one that the IP is able to attach to the device for the purpose of receiving data and locating where it is. Because imagine that we have billions of devices. So how does it know that it is your device that should receive this data that I'm sending? It is through the IP address. So the IP address is this 192.168.1.1, depends on whatever IP is given to it. So path determination too, it receives packet from the network layer and then all of that. So another thing that it does is what they call, so like I've said, internet layer is very important. It actually ensures that information is sent to the right person through the IP address. Never confuse these two together, I mean IP address and MAC address. So IP address is the address that the IP is able to attach to the device to be able to receive data packet, to receive data. But The MAC address, media access control address, that one, every device, if you check your laptop or check your device, there's a MAC address written there. This is basically for locating each other on the same network. If we're on the same network now and information to be sent on the network, we don't really need an IP address, because IP address is to be able to send it from network to system, or over the internet, or whatever it is. But if we're in the same network, a MAC address is enough. So with the MAC address, we can be able to locate each other on the network, because every device has its own MAC address. So sometimes what ARP does is to be able to map, to be able to convert your IP address to a MAC address, or to be able to map it to MAC address so it can be seen. So remember something that should not be confused. MAC address is written by your manufacturer to be able to have the device located on a network, within the same network. But if it has to be between different networks or across networks, then IP address could be useful, because every device is attached, an IP address is attached to every device. It's just like I'm sending letter to you. How will I know where you are except with an address? That address is where I can be able to locate where you are at the moment. So the next layer now is the data link layer. The data link layer and the physical layer in the O.S.I model is what forms the network access layer in the TCP/IP model. And this is very, very important. So the data link layer is one that receives packet from the network layer, and this is where physical addressing is done. Physical addressing is done at the data link layer, so it's able to do the physical addressing and attach routing to the right location. So it allows upper layers of the O.S.I model to be able to access media through techniques such as framing. So we'll talk more on the data link as we move on. So let's talk about the last one, which is the physical layer. That's the last layer, really. And the physical layer is one that converts binary sequence into signal. So it has been sent from the representation layer as binary sequence. It converts it into signals. So that means that it is the last layer. It's the layer that's the last port of call. If you convert it into signal, there are different kinds of signal for it to be accessible by the local media. Different signal. For example, you can convert it to Wi-Fi signals. You can convert it to signal, radio signals. You can convert it to electrical signals, whatever it is. So if I connect an Ethernet, for example, an Ethernet to I connect it to the laptop. Yes, the physical layer is able to give it signal to connect. It's able to give it signal to modem to connect. It's able to give it signal to, if I'm connecting to the laptop to receive information, the physical layer is going to give signal. It sends signal to connect. So from there also it moves up. From physical layer it goes up, down to the data link layer, down to the network layer, down to the transport layer, down to the transport layer. We said that, down to the session layer, down also to the presentation layer, and to the almost part application layer. So it moves like that, application down to physical, physical up to application, and the sequence keeps moving like that. Remember, the physical is the last layer, and that's the layer that is involved in transmitting your information in binary into signals that you can use to be able to attach. So that's the last port of call. You attach whether you do it through Wi-Fi, through physical signal, internet connection. The physical layer is able to convert this thing to signal that is able to send it across. All right, so if you don't understand some part, just keep listening up. We'll keep talking about it until you're able to get it. Thanks so much for joining this class. Join me in the next class.